I know, right? Okay. I think. So I'm going to go over 5 on the front in this video, 5, 6, and 1 on the back. So let's see. We've seen repeatedly that a horizontal dilation does not alter the graph's y-intercept. Given the function f of x and g of x equals f times k of x. So essentially, these are our two graphs, f of x and f of kx, which means it's the same graph as f of x, but it's just been horizontally dilated. We can't tell if it's a stretch or compression because we don't know the value of k. But can you determine an algebraic argument, algebra, for why f of x and g of x must have the same y-intercept? Okay, so the MO, I think we've talked about this once, but I'll say it 1,000 times this year. To find the y-intercept, you set x equal to 0, okay? Y-intercept, any point that's on the y-axis is going to have an x-coordinate of 0. So for a y-intercept, you set x equal to 0. So if you do that for the f function, f of x will be f of 0. If you do that and try to find the y-intercept by setting x equal to 0 for the g function, it'll be g of 0 equals f times k times 0. And k times 0 doesn't matter what k is. 0 times anything is still 0. So that's the same as f of 0. So f of 0 is the y-intercept. And on the g graph, f of 0 ends up being the y-intercept. And those are equal to each other. So it's really because when you plug in an x of 0, that k makes no difference. 0 alone versus 0 times k is still going to be 0 in both cases. So their y-intercept will be the same. And that's the algebraic argument. So that was definitely a tricky one to have to think through. 6, if a function has this domain. Oh no, I wasn't going to do 6. 6 wasn't this class. You didn't ask about that one. 5 on the front, and I said 5, 6, and 1 on the back. So the function g of x is defined there. There's a lot going on there. What 3 transformations have occurred to the graph to produce the graph of g? So we're going to go in the proper order, specify the transformations, and make sure their order is right. The 5 and the negative 5 out in front has to come first. And it doesn't matter. You can address the negative first or the 5 first. This one, or you could do 5 and then the negative. The order of these particular two is not important. So I'll do, it's vertical because it's out in front. It's a reflection because it's a negative sign. And vertical reflections go over the x-axis. That's number 1. So 1. Number 2, the 5 out in front. Vertical, it's a multiplier. So it's a stretch by 5. And then the plus 4 at the very end. Outside, it's still vertical. It's a plus, so it's a shift up 4. And those are your transformations. On the bottom, the answers, do you see how I have that arrow on vertical stretch by 5 and vertical reflection over the x-axis? That was the best way I could show that those first two can occur in either order. And then 6, we have the graph of h shown below. The function f is defined by negative 1/2 h of x plus 3. So again, a vertical reflection, this time a vertical compression, and then shifting up 3. So what 3 transformations have occurred to the graph to produce that? I just said it. Vertical, because it's out in front, reflection. Vertical compression. Vertical shift up 3. I'm not going to write that. I just said it. Graph and label. Okay. So what I would say is with your critical points, 1, 2, 3, 4. With those 4 critical points, take it one by one and go through each of those. So let's say the negative first, then the 1/2, then the plus 3. So on this particular point, it's going to flip vertically because of the negative. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 below. so it's going to flip 8 above. 1, 2, 3, 4, 5, 6, 7, 8. So the flip would bring it there. Then the vertical compression by a half. If it's 8 units away, we need to shrink that down to 4 units away. So we're going to back up or back down 4 units away. And then the shift up 3 is going to draw that 1, 2, 3. So there's point number 1 and its image after all of that. We're going to do the same thing with point number 2. First the flip. 1, 2, 3, 4, 5, 6. It's 6 above, so we're going to drop it 6 below. It's now the compression of a half. If it's 6 away from the x-axis, we're going to vertically compress it down to being only 3 away. And then it shifts up 3. 1, 2, 3. Okay, now this one that's right on the x-axis. A flip over the x-axis when it's already right on the x-axis isn't going to move it. A vertical compression by a half towards the x-axis when it's already on the x-axis isn't going to move it. But then plus 3 would just go 1, 2, 3. So there's your third critical point. So right now, if I had a straight edge, it would be better. But that's what we're looking at so far. And then do those transformations in that order to the last point. So this one is 1, 2, 3, 4 above. Flip it to 4 below. 1, 2, 3, 4. There's your flip. Compress it by a half. So if it's 4 below, it's going to drop down to being only 2 below. And then after that vertical compression, we're going to shift it up 3. So 1, 2, 3. So you see it definitely got flipped upside down. It got pinched in so it wasn't as tall and drawn out, and then it also got shifted up. There's no way I could show you starting graph, ending graph on this particular one and say, what were the transformations? When you have multiple transformations, there's not just one way to make that happen, so you have no way of knowing. Not that it asked that, I'm just like extending a little bit. There's no way to know what that's going to look like until you literally go through the transformations with the critical points and then just connect them. Does that make sense? Okay? Take it point by point to be patient with it, because otherwise it's a little overwhelming. And then this number 1 at the bottom. Which of the following equations would represent the graph of this parabola after a reflection in the x-axis? So let's think here. If you're flipping over the x-axis, is that a vertical or a horizontal movement? What'd you say? Vertical, up, down. So a vertical reflection means the negative goes inside or outside when it's vertical? Outside, always. Everything vertical is outside. So we essentially just, if this was a function like that, we would just need to put a negative out in front. We're just going to put a negative out in front of this polynomial. So it's going to be negative 3x squared minus 4x minus 1. And that negative sign is going to switch all the signs because you have to distribute it through when it's out in front. So negative 3x squared plus 4x plus 1. Negative 3x squared plus 4x plus 1 is option 4. One thing I'll show you I didn't do yesterday, but it is nice for you guys, is you can plot these, and when it's just one transformation, it's kind of easy to see which one is that vertical reflection. So I will type in the original, 3x squared minus 4x minus 1, and then I'll type in the one that was the answer, negative 3x squared plus 4x plus 1, and hopefully you'll be able to see the vertical reflection. There's the first graph. Here's the second graph. Can we all agree that that seems to have vertically flipped over the x-axis? So you can check these things on your calculator just by typing the two functions in. Again, if it's, not that you could type this type of one in, but if there's multiple transformations, that'll be tougher to see. So I wouldn't get stressed out about that. But if it's just one or two things, I think you can just kind of look at them side by side to confirm that you're correct. Okay? So go ahead and put those packets away because we're going to